by looking at this equation, you can identify that it is in quadratic form. We have sine squared and we have just sine to the power of 1. You could go ahead and factor from this form, but if it's too difficult, we can simply let sine theta, not everything in the brackets, there is nothing, but just sine theta equal to x. That's going to make it easier for us to look at. So sine squared becomes x squared, and you can solve for x here. Because we only used x to make this easier to look at, easier to factor, we don't need to use the formula when we substitute back. So now we have two equations to solve. Sine theta equals 1/2 and sine theta equals 1. These are the types of equations we solved in the first two lectures. Remember, we're solving them on this interval 0 to 2 pi radians. Why don't you find theta? We can see that sine is positive in quadrants 1 and 2. That gave us a 30-degree triangle, or that point on the unit circle at 30 degrees. So we see in quadrant 1, theta is equal to 30 degrees. Using the same triangle in quadrant 2, 30 degrees less than 180, we see that theta is equal to 150 degrees. And from our second equation, we see that we're at 90 degrees for y equals 1. Because this question gave us our intervals in radians, we should answer in radians. Let's solve another equation in quadratic form. Why don't you go ahead and solve this one? Make sure you have your statement telling me what x equals if you're using x before you factor, and you found two values for x. Now you can substitute and solve for theta. We just solved sine theta equals 1 in the last question, so I don't need to show any work here. But let's think about sine theta equals 3. Remember last week when we were graphing, we had these equations, sine of x equals y, and we said that our range, the y values, were from -1 to +1. 3 is outside of that range. This equation has no solution. One more equation for you to solve. So you substituted and let x equal cosine theta. When you factored, you found two values for x, and then you substituted back. So we have two equations to solve. Cosine theta equals -1/2, and cosine theta equals 4. Cosine is negative in the first equation. That means we need quadrants 2 and 3. I drew a triangle here, so I can see that the reference angle, 60 degrees less than 180, gives me my value for theta, 120 degrees, or 2 pi by 3 radians. In quadrant 3, the same triangle, so theta will equal 60 degrees more, or 240 degrees, 4 pi by 3 radians. Cosine theta equals 4. That's the same thing we said last time when we were graphing. Cosine had a range from -1 to 1. 4 is outside of that range, so this one has no solution. We like to put these other types of equations on your final exam, and they're worth a lot of marks because we haven't tested you on them. So please practice and be comfortable showing your work.